All right, so we saw a few examples of maybe different possible linear trends and their correlation coefficients. Okay, man, every time students always disappear during the break. Hurts my feelings a little bit. It's not funny, no. But you know, thank you guys for sticking around.
You already know.
Huh? All right.
Who said extra credit?
No extra credit, okay? So what's going to happen is, well, I hope that by sticking around, your learning experience will be better and you will be better prepared for all of the quizzes and tests. So anyway, before the break, we talked, I showed you just a few examples, and I gave you some possible correlation coefficients. These are reasonable values. I'm just eyeballing these numbers here, okay? There is a formula for calculating the correlation coefficient R, okay? But if you thought the formula for finding the standard deviation was bad, the formula for finding the correlation coefficient is even worse, okay? And to truth be told is that nobody today, almost no one, finds the correlation coefficient by hand, unless it's for some kind of exercise. Now, normally we just take the data points that we have, we take our two numeric variables, the pairs of points, and we just give them to a computer or some kind of program, and we say, please calculate the correlation coefficient for me, okay? And StatCrunch will do it for you. Even Microsoft Excel can do it if you know the proper command. And the computer will calculate the correlation coefficient for you. And so I will not ask you guys to try to find correlation coefficient by hand. I think it's not the best way to use your time here. Okay, but before we use correlation coefficient, what must we do? Draw a scatter plot and see if it's linear or not. Okay? So number one thing, before you use the correlation coefficient, create a scatter plot and check if it's linear or not. Okay, that's the number one step. So I'm sorry, before finding R, because you can always find R, all right? You can always take two numeric variables and find R, but you might, based on what you see, you might think it means something that it doesn't. Okay, so before finding R, always make a scatter plot. To see if the relationship is linear. Okay, and if it's not linear, your R, even though you will have a value, will be meaningless. Okay, if it's not linear, the value of R even though it exists, will not be meaningful. Okay. And you can see page 145 shows four examples where the correlation coefficient, where R is equal, I think, to 0.86 or 0.817, or R equals 0.817, but only makes sense for one of the plots. Okay. For the first scatter plot. Okay. The other three scatter plots do have a correlation coefficient R, but it doesn't make sense. Okay, so all this fuss about correlation coefficient, one of the most useful things we can use with correlation coefficients is to make predictions. Make predictions with linear regression. So linear regression is a tool that we use to basically make predictions for one variable based on the other variable. So whenever we're talking about linear regression, we've got two variables, okay? We use one to make a prediction, and the other variable is the one that we are making a prediction for, okay? So we have the x variable is the variable used to make a prediction, okay? I'll just say the x variable is used to make a prediction. The variable we predict is the y variable. Okay. Sometimes this is called the response. So with linear regression, linear means, again, a line. So we're only going to learn how to make predictions for straight line relationships, okay?
Excuse me,
Yes.
when you have the response out from the y variable, is that another way of saying that, or that's?
Yeah, sometimes that's the term used for the y variable is the response. Okay, so straight line relationships, straight line predictions. Okay, so to make this straight line relationship with linear regression, we are going to create a regression line. Now, from algebra, how do we write the equation of a straight line? You guys remember?
Y equals mx plus b.
Y equals mx plus b, right? This is from algebra. Algebra, equation of a straight line is y equals mx plus b. What is m?
Slope.
Slope. And what is b? The intercept. Okay. In statistics, we do the same thing, except we change up the letters on you. All right. In statistics, okay, the equation for regression line is, okay, it's going to be y hat. Okay, I put a hat on the y, or this cap here, is equal to a plus bx. Okay. Anytime you see a hat, the hat on the y means it's not the actual value of y, but the predicted value of y. Okay, so this means not the actual y, but the prediction for y. And we've moved the intercept over here, so the intercept is now a, and the slope is called b. Okay, so I didn't make these choices, but this is what this is how it's done in statistics. Okay, so the equation for a regression line in statistics is y hat equals a plus b.
But the prediction?
Yeah, but the prediction, sorry. Not the actual y, but the prediction for y. Okay, so y hat, this is our prediction for y. So let's say okay, so let's say we've got two variables, and let's say this was, one was, let's say we went to a class, and we looked at, the students took a quiz, and they got a score on the quiz, and let's say they took the midterm exam, and they got a score on the midterm exam, okay? And so let's say the quiz score was based out of 25. Okay, so we have, again, Adam, and we have all our students, and let's say Adam scored, let's say the quizzes are out of 25, and let's say Adam scored a 24 on the quiz, and on the midterm is out of 100, so quiz is out of 24, out of 25, and the midterm is out of 100. Okay? So you scored a 24 on the quiz, and you got a 90 on the midterm. And let's say Bob got a 20 on the quiz, and 83 on the midterm. And Carl got 15 on the quiz, and let's say 63 on the midterm, and Doug got a 20 on the quiz, but a 78 on the midterm, and Ed got a 23 on the quiz, and a 95 on the midterm. Okay, and let's say there's more students. Okay, and this is the plot that we created. Okay, so more students. Okay, does this make sense? What's going on here? Okay, so let's say someone comes along. Alright, Xavier comes along. And let's say he scores a 22 on the quiz. Can we predict what his midterm score might be? Okay? So let's say the regression line y hat is equal to 5 plus 3.8 x. Okay. What does the x variable represent in this case? And what is our y variable? What are we using to make a prediction? So, yeah, the x is what we're using to make the prediction. And what variable are we using to make a prediction? Okay. Maybe, okay. So we're using the x to make a prediction for y. That is correct, okay? X is being used to make a prediction, and the thing we're predicting is y. Okay? What does the x variable represent?
The quiz score?
The quiz score. Thank you. Okay? X represents, this is our quiz score. So we're basically, what we're saying is, based on someone's quiz score, we are trying to predict y. And what is y? The midterm. Okay? Midterm score. And this is because there's a hat, it's the predicted midterm score. So based on the quiz score, which is our x, we are predicting the midterm score, or y. Huh? Yeah, I made up 5 and 3.8. Okay? Alright, I made those up. Okay, we'll talk about how to get those. But for now, I've just made up those numbers. I'm trying to teach you the big picture concepts right now. Okay? So I could, instead of writing y and x, I could actually put in the things themselves. I could say predicted midterm is equal to 5 plus 3.8 times the quiz score. Does that make sense? Okay, these two things are saying the exact same thing, except I've written out what y represents and what x represents. Okay, so if Xavier scored a 22 on his quiz, what do we predict Xavier's midterm score to be? Okay, you might need a calculator for this, but go ahead, punch it out. If you get an answer, don't shout it out. We'll give everybody a chance to think about this. So if Xavier's quiz score is 22, what do we predict his midterm to be? need to round anything yet. Okay, you don't, second quit. Okay, who has a number? Alright, did we get 88.6?
Yes.
88.6, great. Alright, so Xavier scored 22 on his quiz. We're predicting that his midterm score is going to be 88.6. And the way we got that is we just plugged in his score, which was 3.8. 3.8 times 22, and we plus 5. And of course, order of operations, 3.8 times 22 gives us 83.6 plus 5 gives us 88.6. Okay? Is 88.6 his actual midterm score?
No.
No. What is it? It's our prediction for what his midterm score is. Okay? Let's say he scored a 90. Let's say his actual score was 90. So this is our actual score. Okay? So did he do better or worse than what we predicted? He did better than what we predicted. Okay? So the actual score we call this difference between the actual score and the prediction a residual. The residual is the actual score minus the prediction. So in this case, his actual score was 90, the prediction was 88.6, so his residual is 1.4. That means his actual score was 1.4 points higher than what we predicted. Okay, so if you have a positive residual, it means your actual was higher. Let's say Xavier has a friend named Logan. Okay, Logan also scored 22 on his quiz. What do we predict his midterm score to be? 88.6, right? We put in 22, we're going to get the same number out. Okay, we get 88.6. Let's say Logan scored an 80 on the midterm. What is Logan's residual? Negative 8.6. Okay, so the residual for Logan is 80 minus 88.6. It is 80 minus 88.6. So his residual is negative 8.6. Okay? Is this good with everyone? Yes.
What's the 1.4? Is that?
Oh, if you do 90 minus 88.6, you get 1.4. Okay? If you do 80 minus 88.6, you get negative 8.6. So this one's negative. That means Logan did worse than what we predicted.
And the prediction, you just come up with it?
Okay, so let me talk about how we got these numbers themselves, okay? I just kind of presented this equation. I said, I'm giving you this equation, okay? But there is, if you had to do the analysis yourself, there is a way to actually calculate these things, okay? Now, some smart people did some calculus and some complicated math work, and they found out that the way to find the, they basically found the formula for finding the slope and intercept, okay? So to find our slope and intercept, well actually, before we get to how we got the 5 and the 3.8, which I actually just made up, let's talk about what the slope and the intercept mean. Okay, so in our equation, what is our slope?
No, 8 points.
3.8.
look at your notes, all right? So we've got y hat is equal to a plus bx. B is our slope, and a is our intercept, right? Okay, I got it written right there. Okay, so our slope. What is our slope? It's 3.8. Alright, what does our slope mean? Yeah.
Is that like the distance between the dots?
That's the distance
Like
between dots.
The direction line.
I'm sorry?
The direction of the line.
That's the direction of the line. Okay? No. I didn't. Okay, the slope, this is our letter, B is equal to slope, okay? B is equal to 3.8. What does it mean to have a slope of 3.8? What is the meaning of slope? Okay, alright, so, okay, alright, okay, let's just pause for a second. Xavier got 22 on his quiz, and Logan got 22 on his quiz. Now what do we predict their quiz midterm score should be? 88.6, right? So Logan got 22. We predict the midterm to be 88.6. And the way we did this was we did y hat is equal to 5 plus 3.8 times 22. And that gives us 88.6. Is that okay with everybody? Okay. Let's say Jean took the quiz, and let's say she got 23 on the quiz. Okay. What would we predict Jean's midterm score to be? Okay, now we can plug all of this in, but I can say, well, if Logan got 22 and we predicted his score to be 88.6, Jean got one more point than Logan, so I would predict her midterm score to be how many points higher? 3.8 points higher, okay? So I could plug everything in, but I could say, well, Jean scored one more point than Logan on the quiz. So we predict her midterm to be 3.8 points higher. Does that make sense? Okay. Huh? Not like standard deviation. This is slope. Okay? And let's say Hank. That's his name, right? Hank? Let's say Hank got a 21. What do we expect Hank's midterm score to be? 3.8 less than 88.6, right? 3.8 less than Logan's midterm score, okay? To be 3.8 less than Logan's. Okay, so what does it mean to have a slope of 3.8? Yeah.
You rise 3.8 and
Okay, so you're using the terms rise and run, which I don't really think makes sense for this, okay? Which is a lot of times how slope is taught to you. But basically, what our slope tells us is how much we expect y to change based on a change of x of 1 unit. When we change x 1 unit, how much do we expect y to change? That's the meaning of the slope. Okay. Slope tells us how much we expect y to change when we change x okay. So, let's say, so Logan got 22 on his quiz and we predicted 88.6, okay? Let's say Scott scored 12 on the quiz. Maybe Scott's not a very good student, okay? Scott scored 12 on the quiz. What do we predict, or how many points lower than Logan do we predict his midterm to be?
10.
Not 10.
3.
3.8 times 10.
Yeah.
Okay? We predict his school midterm to be 3.8 times 10 lower than Logan's, okay? Does this make sense?
Yeah.
Who's confused? Okay.
I'm a little confused.
You're a little confused. That's
Yeah.
okay.
I don't, where did you get the times 10? Is it 'cause it's 10?
Yeah,
plus
okay,
12
so
or-
Scott scored 12 points.
Okay.
Logan scored 22. How much lower is Scott's quiz score than Logan? Scott's quiz is 10 points lower than Logan's, okay? So we're predicting Scott's midterm score also to be lower than Logan's, okay? Because what we're seeing is a positive trend. So if Scott's score is lower, we also expect his midterm score to be lower. Because the slope is 3.8, we're expecting Scott's midterm to be 3.8 times 10 lower than Logan's.
Oh,
Okay?
okay.
Alright, so the slope tells us how much we expect y to change when we change x by 1 unit. Okay? Alright, what is our intercept then? When we look at this equation. Our intercept is 5. What does that 5 mean? Okay. The intercept is 5. The intercept is our prediction for y if x is what? 0. Okay? The intercept is our prediction for y when x is 0. Okay? So if a student scored 0 on the quiz, what do we predict their midterm to be? We would predict 5. Okay? Now sometimes the intercept doesn't make sense. Okay? Sometimes the intercept doesn't make sense. Or sometimes it does not make sense to have x equal to 0. Okay? Okay, and if that happens, that's okay. You still have an intercept. It just might not have a practical interpretation. We got a little bit more to do. Alright, so how do we get our slope and our intercept? Okay, now I'm going to give you basically the equations or formulas to get the slope and intercept. But the important thing is not the formulas, okay? I mean, yeah, you've got to know those things, but don't lose sight of the big picture, which is what is the meaning of slope and what is the meaning of the intercept, okay? Again, what is our meaning of the slope? What's the meaning of the slope?
How much we expect y to change when we change x.
It's how much we expect y to increase or decrease when we change x or x by 1 unit. Okay, whatever that 1 unit is. Okay, so to find the slope and intercept. Okay, so you need 5 values. Okay. X bar. What is X bar? The mean of X. Okay, and you need Y bar, which is the mean of Y. So how do we get the mean of X and the mean of Y if this is our data set? So let's just say we got these 5 students. What do we do to get the mean of X and the mean of Y? Okay. So what is the mean of X then? How many numbers am I adding up? 5. And I'm adding these 5 quiz scores, and I'm dividing by 5, and that's going to give me the mean of X. Okay, don't worry about actually finding it. And the mean of Y is I take the 5 midterm scores, I add them up, and I divide by 5. Okay, that's how we get the mean of X and the mean of Y. You don't add all 10 numbers together or anything like that. Okay, you also need the standard deviation of X. Okay, that's S sub X. Okay, and you guys know how to find the standard deviation. You do the same thing. Find the standard deviation of these 5 numbers, and then find the standard deviation of these 5 numbers. So what would be the standard deviation of the midterm scores? What symbol would we use for that? S sub Y, okay? And then the last thing you need is R. And what's R? The correlation between X and Y. Correlation between X and Y. Alright, so okay, so to get the slope, so the slope is equal to R times the standard deviation of Y divided by the standard deviation of X. So this is how you find the slope. And then once you find the slope, you can get the intercept. So do this one first, and this one second. The intercept is equal to Y bar minus B times X bar. That's the intercept. Okay, so you need these 5 numbers, and then you can, whatever these 5 numbers are, you just plug them in to these formulas to get the slope and the intercept. Okay? How are we feeling? These are just straight formulas, just plug in numbers and go. Alright, there's nothing complicated about that. Alright, so let's try an example. Okay, so let's let's say we were looking at so let's say we've got a giraffe here. Okay, so we've got a giraffe, and we are going to measure how tall the giraffe is. What's that? You don't like my giraffe? Well, I don't like you either. And we're going to measure how much the giraffe weighs. Wait. This thing is beautiful. All right? Okay. Okay, so let's say Y bar. Oh, let me put it in the same order that I put up there. Oh, now I have no idea. Okay, so these numbers again. I'm making these ones up. Does anyone know how much a giraffe, how tall a giraffe is?
11 feet, 12 feet.
Let's ask Google here.
Huh? Wow. I'd say 20.
Average height of a giraffe. 16 to 20 feet tall. Okay, so let's say we are using the height to predict the weight of a giraffe. Okay, we will use height. Okay, so let's say the average height of a giraffe is 18 feet, and oh my gosh, and the average weight is 3,500 pounds. Is that for real? That's crazy. That's crazy.
That's more than the Clydesdales and the Morgan horses.
Yeah. Well, you'd expect the giraffes to weigh more than a horse, right?
Yeah.
They're much bigger than a horse. If a giraffe, you ever see like on Discovery the giraffes fighting each other with their necks? It's ridiculous.
I don't have animals.
Okay, so let's say Animal Planet. Let's say the standard deviation is 200 pounds, and the standard deviation for a height is 1.5 feet, and let's say the correlation is 0.70. Okay, come up with a line, give me the equation, find the equation, okay, and then, and I'm going to just draw a plot here, okay, and the purpose of this plot is not actually for any use, but this is to show that the form is what?
Positive.
Not positive.
Linear.
Linear, okay? Because linear regression only makes sense if the relationship is linear, okay? If you have a nonlinear relationship, you can do this, but it's totally meaningless, okay? So the shape, form is linear. Okay? So find the slope and intercept of the regression line, slope and intercept, and make the regression line. I'll give you guys a few minutes. Alright, some of you guys are just sitting there, alright? Try. Just because it hurts or burns doesn't mean you're gonna die. Okay, everything you need to know, well, at least for the slope and intercept, is up there on the board. Oh. I looked at the wrong section of Wikipedia, but okay. This is not quite right. So those numbers aren't quite correct. 2630 is the average weight, but we'll just leave it. We'll just leave it. These are fat giraffes, not so these numbers are actually wrong, but that's okay. Alright. Who has numbers? Okay, we'll wait for a few more students to get numbers. Okay. Who's given up and isn't trying at all? Okay. So that means everybody else should be working. And I'm sorry that you've given up and you're not trying, but you gotta try, okay? Alright, all you gotta use, okay, if you have no idea, just use these things to get the slope and intercept. Everything you need, all you gotta do is look at this and look at this, and you should be able to get those two numbers. Huh? Oh, was I covering it? Okay. Well, it should be in your notes, right?
Yes.
Should be in your notes too.
On the quizzes, are you going to give us all those numbers?
Yeah, and if I were to ask you this problem, I would give you these numbers here, okay?
Okay.
Alright, okay, we're gonna run out of time. So, what is my slope?
93.3.
93.333. Okay, so let's say 93.33. And what is my intercept?
18.6.
1820, you guys did some rounding and that's how you got that 0.6, but it's 1820. And so, what is my prediction equation when I put this all together? Y hat equals, can anyone do this? 1820 plus 93.33 times x. Did we get that?
Yeah.
Yeah? Okay. Or I could put what? Predicted weight. I could even put a hat over the weight instead of writing predicted weight. I could say weight is equal to 1820 plus 93.33 times height. Does that work? Okay, do I need to go over how to get A and B?
Yes.
Yes?
Yes.
Okay. So in your notes, you should have the equations for A and B. So B is R times S sub Y divided by S sub X. So what is R? 0.70. What is S sub Y? 200. What's S sub X? 1.5. Alright? And if you put this into your calculator, you get 93.33. Alright, is this confusing for anybody?
How would you, the 0.70 and then how would that all go together?
Huh? How does that all go together?
200 divided by 1.5. Okay.
Okay. So you gotta know your implied algebraic operations, right? There's always, if you just see letters together, it means multiplication. So 0.70 times 200 divided by 1.5. Does the order really matter? No, not here. Multiplication, division, they're all, the order is fine. Okay. Alright, so A equals y hat minus bx. So what's y hat? I mean, sorry, y bar. Y bar minus b times x bar. 3,500 minus, what's b? B is 93.33, okay? This is why I said you have to do this one first and this one second, okay? So once you get the slope, you plug in 93.33 and you multiply it by x. What is x? 18. And when you do that, you get 1820. Okay, so that's how we got A and B. You got 1820 by a totally different way. I don't know what you did, but this is the only way I know how to get it. So it could be a happy coincidence that it worked, or maybe you're actually doing something right, but, huh? Okay, how much do we predict, a draft weigh? If it is 17.5 feet tall. Okay, go.
These calculators follow the calculators. That's why it's crazy. So you can make a parenthesis.
What equation are we using?
Y equals A.
This one, right? Y hat equals 18, either of these, And what am I plugging in? 17.5 in for x or for height. Okay, because I'm trying to make a prediction for weight for y based on x or height. So I'm getting the predicted weight is equal to 1820 plus 93.33 times the height, which was 17.5. And when I do that, I get 3,453.3 pounds. Okay? Is that good? All right. What is the slope? 93.33. Give me the interpretation of the slope in this context. Alright, so is it alright if I erase this? Two. I already did. Okay. The slope is 93.33. Okay? What is the interpretation? Pay careful attention. Okay? This tells us that for each additional foot in the height of a giraffe, right? This is an additional unit of x, right? X is the height of a giraffe in feet, so each additional unit of that, so each additional foot in the height of a giraffe, we predict, and it's very important that we predict, okay? We predict the weight of the giraffe to what?
Fluctuate like 93.33.
Fluctuate is does not imply which direction, but we want positive. So if the height goes up by a foot, we predict the weight to go up by 93.33 pounds. So we predict the weight of a giraffe to increase by 93.33 pounds. That is the interpretation of the slope, okay? For each additional unit of x, we predict y to change by the amount of the slope, okay? So the general form, general interpretation for any scenario for each additional unit of x, we predict y to change by the size of the slope, by the slope. Okay. So for each additional foot in the height of a giraffe, which is our x, we're predicting y, the weight of the giraffe, to increase by 93.33 pounds. Are we good?
We're good.
Okay, what's our intercept? 1820. 1820 is our intercept. What's the interpretation of the intercept?
That's how much a giraffe would weigh if it wasn't any height.
Yeah, it's our prediction for y if x were 0. Okay? In this case, so that means we predict a giraffe to weigh 1,820 pounds if it was 0 feet tall. That doesn't make sense. You can't have a giraffe that's 0 feet tall. It's a non-existent giraffe. Okay? And it clearly doesn't make sense that a non-existent giraffe would weigh 1,820 pounds. But that is the direct interpretation of the slope. It doesn't make sense, okay, in our context, but the interpretation of the slope is our prediction for y when x is 0.
Wait, don't you mean the intercept?
Oh, I'm sorry, interpretation of the intercept, sorry. Thank you for that. Is our prediction for y when x is 0, thank you. That would be a big mistake. Okay, I'm running out of time. Okay, let me just write a few warnings, okay, about regression. I apologize for going over time. Alright, warnings about regression, okay? Correlation does not equal causation. Okay? Just because it seems like two variables move in the same direction or opposite direction doesn't mean one variable causes the other variable to change. Okay? The other is, do not use regression to make predictions outside of the range where you gather data. Okay? And people do this all the time in bad science reports. They say, oh, you know, between the years 2000 and 2013, we saw this thing increasing steadily by, 200 points each year. And so that means by the year 2050, we are going to be overrun by this whatever thing, okay? We don't know what's going to happen in the future. Okay, we've never gathered any data beyond 2013, so we can't make it true predictions. But people like to use regression and project out beyond where they where they gather data, and that's no good, okay? And then the last thing is outliers can really mess up your regression, okay? Really mess things up, so be careful. Okay. All of these things are talked about in a little bit more detail in the book. I'm sorry, we're running out of time to talk over those things, but read the book and do your homework, and we'll see you guys next week.